So this is a SOI Asia Research Workshop. The main idea here is to introduce a bit of the research that we're doing, mainly the partners are doing. And then as a brief introduction of SOI Asia, I hope everyone attended the plenary yesterday, where Keiko-san gave an introduction of SOI Asia. And I believe everyone knows that this group has been a while. I'm not saying it's old, but it's been a while in this internet space. And then we're going to have our 59th meeting from tomorrow in the 3rd floor. So that's why we strategically collocated the meeting with APAN. And then it's good to have members from SOI Asia and the APAN community to come. Today, by the way, my name is Husni. I'm chairing this session. And what we're going to do today is we're going to hear 3 presentations. I know it's a 1.5 hours, and I just made it into 3 presentations because I think there are for 2 reasons. One is, even though we're in the SOI Asia community and we're doing a lot of things, education, research, and not everyone knows what everyone else is doing. So it's a brief, short introduction of what we're doing in the research, as well as we hope we can have a very lively discussions. So that's why I only put 3 speakers here. And if you're interested, tomorrow we will have poster and demo sessions downstairs on the 3rd floor. Precisely is a G318 and 319. I hope the room is correct, right? Yeah. So yeah, right down that group. So that's just short introduction of the session. And for today's presentation, we will have Chong Yung Wei from USM. She will present the research activities that we have in IoT, both in the transport as well as in agriculture. And then followed by Niswar from Universitas Hasanuddin, Indonesia. He will present or give an overview of our work in the cybersecurity. And then the 3rd and the last presentation of the day is by Abbas from Universitas Brawijaya, Indonesia. So he will give you an overview of what we're doing with LeoSat, especially, well, we're using Starlink to be precise. And hopefully, in between presentations, ask questions, get into more details, and then after that, if you want to know more, we have demo sessions tomorrow. Okay, with that, I think, John, take it away. Thank you.
Okay, thank you very much, Professor Husni. So basically, I'm going to present about one of the project, what we call a CBR project, community-based research project, focusing on AIoT at SOI Asia. So basically, based on Professor Keiko's plenary session yesterday, I think SOI Asia has been a while, and there are a lot of activities that we are doing. What I'm going to present is actually on this area, which is a community-based research framework. Inside this framework, there are actually quite a lot of projects that is under here, but I'm only going to present 2 of them, okay, or 2 of the sub-projects in IoT. Basically, like what Professor Husni said, in the smart transportation and also in agriculture. So basically, what we have been doing in these 2 spaces. When we started in the transportation phase, Basically, one of the issues that we find, especially in Southeast Asia, is that the commuter actually cannot see when is the ETA of the bus. And although we would like to put in like GPS, etc., to monitor real time, but we face challenges because quite a lot of bus operators are actually reluctant to be monitored using GPS because they don't want us to do any tampering on the bus. So what happened in this project, we actually use beacon and also a gateway to monitor, like when the bus pass by the bus stop, we actually understand, and using machine learning, we actually predict when is the ETA for the next bus stop. Yeah, so this project is actually a collaboration project. SOI Asia is actually about collaboration. And we have partners from USM, Malaysia. We also have from Universitas Syah Kuala, USK, from Indonesia, and also Universitas Brawijaya from Indonesia as well. So here we actually deploy the platform for all the 3 different sites to test out and to also let the student learn about how to use beacon technology for detection, and also how to train the models as well. Yeah. So basically, if you can see here, these are the deployment. We have the gateway, we have the beacon that we put it in the bus, and also from the CBR project, students are actually required to develop applications. Actually, it's a full stack development. So they also need to work on the back end as well. And in this case, we actually use cloud services like AWS. From the project, basically, we published quite a number of joint research papers. These are some of them. You can actually go to SOI Asia publication website that you can see here to look for more details. Yeah. So basically, at the same time, when we talk about smart transportation, then we also look into, okay, how we want to solve the problems that the farmers are facing in the agriculture area, because I think this project initiated from Indonesia, but we also face the similar issues in Malaysia as well, because human resource is actually a critical problem, especially in today's world where people doesn't want to work at the field. And although Japan is cold, but in Southeast Asia it's usually very hot, and nobody wants to work in the field. Okay. So if you can see here, these are the typical farms, and basically when the farmers work on things, it's usually manual. It's very common that they do manual process, like for example, sorting, harvesting, and etc. So all these are manual process. And in Malaysia, we rely a lot on foreign laborers because not many Malaysians want to do the job. Yeah. So one of the things that we discuss is how do we want to start to use IoT and AI to help the farmers as well, to automate certain process. Yeah. So basically we sort of like, okay, maybe why don't we just develop something where we can use camera to detect the to see the images, to classify, and also predict the grades, so that we can automate certain process. And also, of course, the device needs to be connected as well. So we can do the inference at the edge computer, but we need to store the data, etc., in the cloud as well. So basically, this is where the CBR3B actually was produced, where we want to automate the process to classify and predict the quality of the produce. Yeah. So if you see here, at the initial stage, it involved a lot of data collection, because most of us that works in this area, we are actually computer science or computer engineering graduates. We know nothing much about the agriculture space, but we are teaching the students and we learn how the field actually works. So there are a lot of data that we collected from all the different sites, and based on this data, we actually do labeling, classifying, and also understand how to develop the AI models to do the prediction and also the classification based on the image. So if you can see here, basically we have partners from Universitas Brawijaya Indonesia, Universitas Syakuala from Indonesia, and also Hasanuddin, Universitas Hasanuddin from Indonesia as well. And of course, USM is also part of it. So you can see here, we actually have the conveyor belt in all the different universities. Each of them actually developed locally because it's not cost efficient if we actually ship from one side to another side. And at the same time, we are actually training the students as well to collaborate and also to work on things together. So all these data we actually share among all the partners as well. Yeah. So similar like the previous transportation project, we also did quite a lot of joint publication together with all the partner universities. These are just some of the publication, but please go through the website to see the full list of the publication. Yeah, and from here, one of the things that we notice, which is why community-based research collaboration is very important. And it truly brings the spirit of SOI Asia as well, where community matters and also collaboration matters. So because of these CBR projects, we learned that we need to teach the engineers real-world engineering skills, not just by theory, but allowing them to actually apply. I remember when the students actually have to go to the field to collect the data, etc. It's kind of hard because it's hot, basically in Malaysia. But at the same time, they understand the problem and they brainstorm how to actually help these farmers in their work. Okay, so we kind of develop the real-world engineering skills for the students. And at the same time, it actually creates a learning experience that no coursework actually can provide because it's so different. The problems that they face in the field is very dynamic. I remember the student have to go to multiple farms. It's the same for USM or all the other universities as well, all the other partners, because different farmers may have different grading system. And we kind of have to learn. And from there, we understand like, okay, what is actually the gap that they have and how we as graduates or as the university can help to bridge the gap. So it's not something that a theory or whatever you learn in class you can get, right? And also, we teach the students to design solutions actually for SDGs. If you see from the agriculture projects, it's actually to address SDG related to food security. And also for the transportation, it's meant for the smart cities, because if the commuters know the ETA, etc., then they can actually plan their journey better. And also, from these CBR projects, we actually can foster innovations, basically because we have different partners. It's not from one country only. And from different partners, we learn the issues that they have. We have a diverse data. We have a diverse knowledge. And also we share among each other. And also we want to promote the social responsibility for the young engineers as well. So the most important thing from the CBR project is the communication skills. I remember before the students actually learn or join the CBR project, they're like usually in their own space only, especially in today's digital world. But from here, the CBR project, they have to learn to communicate with students, faculty members from different countries. And tomorrow you can actually see them doing a demonstration and showcase as well at level 3. That demonstration is actually from students from different countries, different institutes, actually coming together to do the demonstration and the showcase. So it's a very dynamic yet very vibrant community that SOI Asia has. And through all this community-based research, we actually can teach the young graduates how to work together for a better future. Yeah, so I think that's all from me. Arigatou gozaimasu. Yeah, if you have any questions related to any of the project, you can let us know. It's a very brief one because based on what I understand, we just need to give an introduction, right? Yeah.
Yes, thank you, Chong. It's a very wonderful message, and I believe, again, through the project, people, well, mainly students learn how to put things in practice, right? It's not just, if you see the cloud and then sensing and all the IoT stuff, it's not the IoT that is in vacuum, right? But you have to put it somewhere. I think that is the message. I think with that presentation, I'd like to open this for Q&A. We can have 5 to 10 minutes if you want, if you have any questions, anyone. The mic is over there. Is there any mic that can be, is there any wireless mic that we can, oh, there's one more mic. Thank you. Thank you. Yeah, Aru.
Hi, John Sensei. Thank you very much. A wonderful presentation, the message and summarization of the benefits of the CBR. We are very happy to hear that. And looking at your final summary benefit of the CBR, I feel like maybe we could make it some sort of program for the students, research practice program that might be longer term, maybe period of year or at least one semester. And we do have some methodology of looking at the field and get the data and analyzation in EBA. So probably we could a bit combine those fundamental, methodology course and practical things, EBA and CBR might be a good idea. So do you have any comments on that collaboration?
Yeah, that is very good suggestion because I think from EBA is usually quite short.
Right, only 10 days or so.
Yes.
Yeah, but these days we have a pre-course.
Yeah. So it's very good suggestion where we actually combine the real world and make it like either a semester or 2-semester program where we teach them give them a project where they can actually do hands-on as well, or develop a solution based on specific topics, because that can actually encourage them, I say, the analytic skills, creating innovation solution for the community, which I think is very, very important because SOI Asia is also about the community as well.
Right.
Yeah, so that's a very good idea.
Thank you. So maybe we could discuss further to implement that program as a pilot first.
Yes.
Thank you so much. Thank you for your presentation.
Yes, thank you very much. Any other question? Yes. You can ask technical questions as well. Chong is very, very technical as well. No issues.
Yeah, hi, I'm Karma from Bhutan. Thank you very much. I think, like the message is very clear. I think the community-based research activities, I think really helps student grow. But I just wanted to know if you had whatever you research CBR activities, that both transport and the agriculture that you have implemented, has this been rolled out with other stakeholders like transport, like your transport ministry or maybe agriculture ministry? Did they adopt some of the findings and also the implementation?
Yeah, so basically for the transport, basically we work very closely with our university bus operator. They actually wants to roll this out as well. Yeah, so it's actually in process to discuss about the cost for long-term sustainability. Yeah, and because they want this to be available for the students. So basically, we actually did a field trial. And also for the agriculture, we did a field trial with the farmer as well. And we actually deployed one of the machine to one of the farm. And we are in the process of deploying another machine to another farm. So it's a two different farm because it's two different fruits that we actually collect the data, do the prediction, and etc. One is in guava and one is in pineapple. Yeah. So we did a field trial, and of course we hope that they can continue to use. But the issue that we are facing for the transportation is actually the long-term sustainability in terms of the cost. Yeah.
Yes, thank you. Yeah, I guess that's always the thing when you move beyond the proof of concept engineering, the sustainability will be the main issue, right? So I think that's one of the lesson learned, and I think everyone knows that, and now we're trying to figure out how to make things work in the deployment, right? Right. Yeah.
Yeah.
Yeah, that may work. Any other questions from the floor, the audience? Everyone's good? Okay. Otherwise, thank you very much, John.
Okay, thank
Okay,
you very
thank you.
much.
Next, we'll have Niswar. So Niswar should be over there. We'll give an overview of the cybersecurity project that we have. I believe in APAN, we have several sessions related to cybersecurity. At least there's a panel or sessions that one of our group members are joining in the cybersecurity. Shankar is joining some other sessions, and also I also joined the session this morning when one of the two presenters talk about cybersecurity. Both in the theoretical, but with that, I think maybe we can see something in practice once the presentation is ready. All right. Okay. I think that's I think the slide is ready. I'll give the time to Niswar.
Okay, thank you, Husni, for giving me opportunity to introduce one of our CBR project, which is CBR2. So, good afternoon, everyone. Good to see you again. And my name is Muhammad Niswar. And today I'm going to present our research on real-time malicious TLS traffic detection using machine learning classifier. So this project is collaboration between 6 universities, partners here, Unhas, Brawijaya, and Science Malaysia, Shah Kuala, and Bangladesh, and also don't forget Keio University. So, so as we know that the cyber threat are continuously evolving, and attackers are using encrypted network to conduct malicious activities. And as a report shows that over 87% of all cyber threats were delivered through encrypted network. Therefore, detecting malicious TLS traffic in real time is important in cybersecurity because since traditional security tools have trouble checking encrypted packet, so machine learning is needed to detect threat without decrypting the data. So the objective of the project is we are going to build an efficient machine learning system that capable of detecting malicious TLS traffic instantly while handling high network loads. And of course, we want to enhance data collection methods and adapt models to different network environments to ensure high detection accuracy across various conditions. And also we going to optimize data processing by using parallel micro-batching to reduce latency and improving real-time detection performance. So this figure shows, so this is our system development. So on the top figure, you can see that the high-level topology, so where each partner hosts on-premise, they host on-premise malicious detector server that capture and analyze network traffic in real time. So when malicious traffic is detected, then the server sends to the data to the central malicious collector hosted in the cloud. So the cloud server gathers data from multiple detectors, help to analyze the threat, detect the pattern, and improve security across all locations. So this setup ensure efficient and scalable threat detection while reducing the load in the local system. And in the figure on the below one there, so that's machine learning pipeline for network traffic analysis, which is divided into two-phase, modeling and inferencing. So for modeling, here we capture network traffic, undergoes data pre-processing, and we extract the important feature, and then we model the training and model validation in order to build the accurate machine learning model. And in inferencing phase, here we capture the live traffic and process using our trained model to predict whether the traffic is benign or malicious. So this is actually the overview of our system. And this is the important part of our system. So here, we also propose multi-source domain adaptation framework for machine learning-based malicious TLS traffic detection across multiple university partners. So here we have 4. Actually, there is Bangladesh, we forget to put here. So yeah, so in the source domain, each institution or each partner collect network traffic data, which is then processed into the dataset and used to train the individual machine learning models. So the trained model are then deployed in the target domain, then where they perform the real-time inference at their respective location or in institution. So this setup enable knowledge transfer between the different domains, improving detection accuracy while maintaining local adaptability. So this is our malicious detector server. So we install machine for malicious detector with the following specification. So we have a Intel Xeon Silver with 12 core CPU and RAM 32 gigabytes, and we have quad port NIC and NVIDIA RTX Quadro A2000. So every partner hosting this machine on premise in the data center. So this is our research activities. So actually this project is still ongoing. So we use Suricata, which is one of the IDS tools for capturing TLS traffic. And we also deploy Teapot, Honeypot to collect attack traffic for building a comprehensive ground truth dataset. So in order to verify the malicious traffic, whether this is malicious traffic or not, then we use, so each Teapot log alert is cross-checked with the Suricata alert log. So if match, then we store it as a verified attack. Otherwise, we store as a false negative by Suricata. So this means that Suricata failed to recognize that this is the malicious traffic. This is for malicious traffic verification. And the other one is we also conduct feature extraction. We want to extract important feature from network traffic, like packet size, TLS, handshake, and then we pre-process the data for analysis. So we also benchmarking all machine learning models. So we will evaluate several lightweight machine learning models like decision tree, random forest, because we are going to deploy in edge. So we try to looking for the lightweight model that do not burdensome the machine. So this model will be trained and validate and fine-tune to achieve optimal performance. We also combine use of several technology like XDP technologies and OpenMP for speed up the packet processing. As we know that we are going to deploy in high volume traffic environment, so we need technology that can speed up the packet processing when we capture the data. So here we implement XDP technology for high-speed packet processing, and also we using OpenMP for workload distribution across CPU cores, so to enable efficient processing in high-traffic environment. So we also evaluate the performance of our system by assessing the accuracy, precision, recall, F1 score, and latency to determine its effectiveness. And also we evaluating various machine learning models to determine which one performs best, based on the above metrics. And of course, we do measure how well the model perform on real-time environment. So far, we have facing some challenge because currently every partner try to collecting data, and I have several students working on this, and they encounter some challenge, like a data imbalance. So usually benign traffic, it significantly outnumbers the malicious traffic. So this can lead to the bias model. So I think some students try to solve with the oversampling by creating synthetic attack to make more balance between benign traffic and malicious traffic. And in high-speed network, there is a need to process large volume of data with minimal delay, and real-time detection system must operate under strict latency constraints while maintaining accuracy, which can be difficult when handling massive traffic volumes. Yes, of course, computational overhead of the ML models. So we try to figure out the lightweight machine learning model. Okay, there are some preliminary results that our partners have been published in conference and journal. And for future direction, we are going to further optimize the real-time detection with XDP technologies, improve dataset generation for intrusion detection system, and we are going to expand testing with the larger and more diverse network environment. I think that's all. If you have any comments, question, thank you.
All right. Yeah. Thank you, Niswar. So this is again, this is a research in the cybersecurity. I think as to emphasize several things. One is this. I think this is the first time in our partners where they install a network tab. Of course, this will make things good for next few years. Good means that we will have capabilities to produce data sets because as we know, the traffics and the challenges are changing. And then this is also combined with honeypot. So we can have both real attacks, and also the group is planning to do simulated attacks as well across the partners who are involved here. So hopefully we will continue to produce data sets coming out from this group. I think the only limitations that, one of the limitations that we can think of here is since these are university networks, so tend to be probably the attacks tend to be quite similar because attacking universities are different from attacking enterprise, right? So I believe these are the things that I think everyone has to be aware on the limitations. With that, I would like to open Q&A for 10 minutes on this. Anyone who would like to ask questions? Yes, 1, 2, yes, go ahead.
Hello, I'm Marlo from the Philippines. I would like to ask, you mentioned that when you detect a malicious traffic and it appears in the TPAT log, but it's not flagged by Suricata, you tag it as false negative, right?
Yes.
Yes. do you do any other analysis on that packet, or you just tag it as false negative?
Yes, actually, we put the honeypots for verifying whether this is malicious attack or not, to get the ground truth.
Okay.
Of course, Suricata is signature-based filtering, right? So we are not using signature-based filtering. So Suricata is just for collecting data, and then we compare the alert recorded by honeypot and the Suricata. So if alert log found malicious attack in honeypot and they don't find in a Suricata, so just false negative. So we don't do anything.
Wait, you don't. Okay.
So that's it. Yeah.
That's it. I see.
Just
Yes, for tagging it and for
yes,
further
tagging it,
analysis.
yes.
Okay.
to just verify that, to help us labeling later on.
Later on.
Yeah.
Okay. I actually have another question.
Yes.
Is how do you handle feedback for your model? Because as you train the model, you feed it more data sets, right? How do you handle the feedback on training the model or improving the model again?
Of course, to improving the models, I think we need to collect the data frequently, right? Because we don't know, because we know that threat is evolving, so their new threat will be coming. So we always updating the data set,
Okay.
and we optimize our model based on that database.
So you just incorporate the new data into the
Yes,
previous and then run
yes.
it up. Okay, so thank you for answering.
All right, thank you for the questions. Next question, anyone?
Yeah, thank you. I think very nice to have this machine learning detection for the cybersecurity. Okay, one thing is that I will ask you: did you have refers to any something like a data set from something like a CVE, common vulnerability exposure? Because in CVE there is more than 24,000 vulnerability. So maybe one of the things, like there is some TLS vulnerability. Did you have put some data set from something like the CVE to analyze and to compare and to training with your data around in the 6 university? Thank you.
Yes. So actually, we currently still collecting the data. So we collecting the real data. We are going to create our own data set instead of using the other data set. Yeah, that's, I think.
Yeah. Did you compare with the CVE released by the CVE.org? Usually they release the data and data set and the vulnerability in some.
Also, so you mean the rules?
Yeah. I mean, I mean, they have the vulnerability side, vulnerability, and then we can
Referencing.
reference this, and then as a data set, and then maybe when you measure the data from your circuit or your TLS log, you can compare, and then maybe you can have something like some more precise prediction with.
Yes, that's referencing will help us when labeling the data.
Yeah. And what about the statistic, like a mean square and root mean square training of the data?
Well, actually, we have 5 partners. They try their own models.
Oh, okay.
But unfortunately, I cannot show the But mostly they are accurate, 99%, sometimes 100%, but sometimes I suspicious that this is overfit.
Okay.
So,
Yeah.
so we have to go through again to
Okay.
check. Yeah.
Yeah.
Thank you.
Okay, thank you.
All right, thank you. Any other questions? Yeah, well, yeah, go ahead.
Thank you for your hard work. My simple question, what is the benefit that you did this project together with other partners?
Well, the benefit is our students have, of course, they improve their communication skills,
Okay, great.
the knowledge, and also teamwork.
Okay,
Yeah.
good.
So the main benefits.
Okay.
So we share knowledge. So if somebody don't know about this, then the other partner can help each other, something like that.
Okay, so you share the issues with
Yes,
other
issues.
partners, and
Yes.
then models that you developed,
Yes.
kind of joint efforts. Okay.
Because we conduct monthly meetings for
Okay.
CBR2 especially. So every partner raise the issues, then we try to solve together. But sometimes I feel that this solving the technical issue through online is not really effective. So I hope that we can get another grant for some for technical meeting, something like that. Because actually our CBR2 is by the time is completed, but
Yep.
but still we are not finished yet. So we are, otherwise the cybercrime also evolving, right? So
Yes.
we need to collecting data every day, I guess. Yeah.
So those models are already applied to their own campus network?
Yes, they
Okay.
already
Great.
apply. USK, Unhas, and Brawijaya.
So the model, usually, learning model, it can be shareable with other
Yes.
partners.
Yes.
Then, okay,
Yes.
that'd be great.
Yeah, so at this moment, that is still not happening. But what we expect in the future, as the infrastructure is in place, and we have I think partners have the capabilities now, more and more. And I think what's going to be one of the contributions of this research is a data set. So not only from one institution, but we have
Right.
several data collection points that we
Right.
have, and we expect to have different attacks that happens on the network. So we can have a better data set than the ones that are available.
Right. I think the sharing the data set is
Right.
also very important as a research output. And these days we can get the DOI for the data set, not only papers.
Okay.
Right.
So
Okay.
please think about how to leverage our output.
Yes, that's our main purpose. Yeah.
Yeah, thank you. Any other questions? Yes, go ahead.
Hi, I'm Colleen from the Philippines also. I'd just like to ask if you tested the different kinds of packet processing, because in the implementation you used XDP.
Yes.
And if by any chance, have you compared it with the performance with DPDK, for example?
No, I'm not. I'm not compared to any technology yet. So we using XDP because XDP can speed up the
Yes,
they can bypass the
Yes.
kernels, goes to the application user space.
Yes.
So in the user space, we deploy the machine learning classifier.
Yes.
So that's the purpose of using the XDP to speed up the, because traffic is high speed traffic is incoming, right? So we have to what we call speed up the passing the traffic to the the machine learning classifier fastly. So otherwise we get packet loss. Yeah.
Yes, because I saw that since XDP, one of its use cases is it can go to the user.
Yes.
So, and then you saw some. What are the future works again about XDP? Are you going to?
I'm going. Yeah, actually, there are one working group working on XDP.
Yes.
We try to find out research topic that performance of XDP,
Yes.
especially. But actually, if you have smart NIC,
Yes. Yes.
yeah, then we can do a lot of research work on XDP.
Yes, of course, yes.
But unfortunately, smart NIC is quite expensive.
Actually, yeah.
Yeah, so yeah.
That's the limit. Okay. Thank you.
All right, thank you. So yeah, again, it's XDP is the one of the things that you can use DPDK. I think these are the two main things that are available now. I don't know how well they differ, but in my short experience with both, both are still pretty good enough for the cases here. This is still fast traffic, but not that fast. So that kind of thing. It doesn't go beyond 10 gigabps. So yeah, beyond 10 gigabps, a lot of headaches, right?
Doesn't work.
Yeah, all right. Yeah, any other questions on this one? All right. Yeah. It's well, when it's more than 10 gigabps, it's a 10 to 100 times more money and the headache. Yeah, it's a good problem. Yeah, that's the right way to put it. It's a good problem. All right. If there's no question, I think let's thank Niswar. Thank you for the presentation. All right, I think we're quite on time. Now we're going to the third and the final presentation of the day. Abbas will talk about the experiences in using LEO satellite, Starlink, as a backup for runs. Thank you. Oh, before we go, just a bit of a side story of the CBR2. CBR2, one of the side results of this cybersecurity thing is everyone have more experience in optical networking. So that make one of the results is in the API camp last time when we had API camp with the optical networking. Yeah, that's a side story of that. With that, I think let's give it the time to Abbas.
Okay, thank you. Yeah, good afternoon, everyone. So here, well, others already presenting the publications of the research. But this one is, we call it as an experiment because we just started last year. And in fact, like we did it, some of the drills just during some specific event like last time in the APAC camp. So the collaborators in here, our institutions like UB, Universitas Brawijaya in Malang, and also the Manado side, which is the Universitas Samratulangi. So why we call this as a solutions in emergency situations? As most of you already know, or everybody knows about the hype of the Starlink connectivities, that we can really use it in many situations. I guess like back to several years before, like among the ASEAN countries, like Indonesia was one of the first perhaps that may be adopting this Starlink because the situations of the countries. But in fact, the Philippines are going first, like it's can serve, right? But now I will not talking about the hype kind of that things, but we things in the groups like how we can utilize this LEO satellite solution. It's not always the Starlink. Recently, we have OneWeb and the others coming up. But in fact, people's like very amazed with some sort of performance of high bandwidth and low latency compared to the earliest solution with the satellite. We usually like low bandwidth and also some sort of very high latency. How about this? Something like that. So that's what we want to explore. And considering about the bandwidth, we are thinking about can it be used as a backbones of the RANs? So that's what the scenario that we are thinking about it. So we did something like, of course, we are not going to turn off the internet of the university because many people feel sold out. In this case, since Unsrat, the Samratulangi University in Manado, is also connecting to the IDRAN, and coincidentally, like UB in Malang is one of the IDRAN gateway. So in the usual situations, normal operations, usually I will go directly to some of the picture first. So usually Unsrat is connecting to UB also for the IDRAN connectivity. It's like up to 100 Mbps, and then usually provider managing the terrestrial links between Unsrat to the UB for the IDRAN gateway. So that's the situation. But the case, I'll go back to this site, is basically what we are triggering during these emergency drills is like we try to trigger one of the link value on the terrestrial one. So it means like just shut down the BGP sessions on the terrestrial ones, but we're also creating the BGP sessions that utilize the L2 link over the VPNs that created or provided over the Starlink. So there are certain situations, and each site is basically using fully Starlink connectivity. So it's like we can call it 2 hops of Starlinks. So 2 hops Starlinks. So you can imagine that we may not really utilize the downlink capacity, but mostly the uplink capacity between the 2 sites, something like that. So here's some sort of the situations, but on the top one is some of the experience we utilized, like just using the portable battery and everything. I mean, it's like completely disconnecting, something like that, from the grids. And we usually, this type of setup is also can connect to the internet. And this is the real installations in our campus in UB. It's basically put it outside of the building is one of the balcony and must be like open space to avoid some obstructions. So to summarize, this is the the illustrations of, it's not only this is based on the smoke ping common tools that to measure or at least to record the round trip time. So this is the terrestrial line properties usually. So this is like from Manado up to, and then going through like to Jakarta first and then go to Malang. So it like round trip time around 25 milliseconds. But once we turn on it shut down the BGP session over the Starlink one, terrestrial one, then it will change into the Starlinks. And then there's some adaptations on that. But we don't really measure about how much times. But the point here, if you just want to see the round trip time. So when it used the two-hop Starlink, the properties of the latency is like this. It's worse. It's not really good. But then we tried to the other experiment. We need meanings like half of the Starlink and half of the terrestrial. Meanings like only one side that use Starlink, but the other side is still on the terrestrial part. So it means like thinking about the scenario, maybe in Manado, because Manado is connecting to the main, most of the connectivity is centralized in Jakarta or in Java. So even though like Manado sometimes need to have connectivity to Makassar and then go to Jakarta. The situation sometimes, and in fact the real situation, cable to go to Manado is very limited, and there are some possible emergency situation. For example, like whenever there's like earthquake that make failure, all the cables go into that city. So according to the discussion with our provider, usually the emergency that they did is, the backup solution they did is using some solution going to the Makassar for using like satellite or whatever kind of solution to that. So, but the rest of the part is still using terrestrial. So this is the idea is that why we need to use it. And in fact, when you see on the round trip times, like this is not that many spike as the purely two hops links. So the remaining picture is explaining about the experiments. So in here, I'm sorry to go into some sort of to details, meanings like these BGP routers at Unsrat, and then usually each of the provider will provide the L2 link using their own solutions, but at the end, basically, that link is using terrestrial links. And in addition to that, what we ordered on the Starlink connectivity, we installed Starlink high-performance nodes at GB and high-performance node at Unsrat, and then try to connect that with the also the routers. So that's why we have two endpoints, BGP session. So BGP session over the Starlink and then BGP session over the terrestrial link. So this is the operation, but in normal operation is using this, and this link is like 100 Mbps, no issue. Usually lightweight usage and 100 Mbps for bidirectional or symmetric bandwidth is achievable. So this is usual use case, like not much jitter. But anyway, this one is a recording on directly on some sort of the NAP box monitoring. So just trying to measure the throughput during the experiment. So of course, like it could reach up to 100 Mbps, something like that. And that's the terrestrial link. And when we use the two hops Starlink, two Starlink using a provider managed VPN, actually one of providers in Indonesia that resell this, Telkomsat, known as one of the company that have the backhaul solution using Starlink. And according to them, there exists some sort of experiments, or it's not experiment, solution that combine perhaps up to 10 Starlink connectivity as a backbone. And they have some sort of special equipment to combine those 10 kind of things. But in that case, we just utilize some solution from them, means like they are providing the L2 over Starlink. So at the endpoint, we're just receiving the L2 connectivities. So just this endpoint and this point can directly ping each other, and then that's why they can do the BGP session easily. It means when we when we receive this kind of situation, usually we can just call to them and then we activate the link. And when we ask to the provider, basically as a backup solution, many providers also utilizing combined 5G and satellite links whenever there is some cable cut, at least to maintain the SLA kind of things. So avoiding some penalty perhaps. So because to combine the cut fiber optic one, you need, takes time, right? It takes time. So that's why usually the provider struggling how to survive with, if there are no other cables, then try to other solutions like satellite and 5G or cellular. And here, as you expected, the latency is not that, means still not good enough. But the thing is still reasonable to be used. But however, from these properties, like, because we just only use the uplink capacity from the two sides. Yeah, I mean, it's like from UB is also uplink capacity for the Starlink, and Unsrat is also like that. So we never reach those 100 or even more than 100 Mbps. Because common Starlink node as a commercial one is only, as far as I ever measure, is can only sustain up to 40 Mbps uplink. For the downlink, yes, it can reach up to 300 Mbps. And Starlink, during heavy rain at one side only, this is happening only in UB, we capture, the signal quality can reduce significantly and no connections. So that's the situation. Yeah, I think AAAI have been doing like UK band, something like that, the property of satellite connectivity using that kind of spectrum is, yeah, we need to really do that. I mean, how to say, meanings like we cannot really rely on that if it is affected by the nature problems. And also not only for the raining, I guess, sun something, electromagnetic wave, something like Starlink last time, yeah, flare, solar flare issue also. And yeah, this is the situations, and okay, this is the last one. I mean, it's like we also try to do the previous one. We rely on the VPN being created by the vendor or the ISP. But this one is we try to create our own, meaning like try to utilize only one site that utilize Starlink, but the other are still using the terrestrial links. So when it triggers the failure on these links, and it will search for the VPN client and VPN servers that we already set. For example, a VPN server at the Unsrat and VPN clients and UB, and then the rest, it will create the L2 link for the VPNs. And this one is like creating this much better situations. I think that's among other details. Well, I have another data, but I don't want to go that complicated, but I'm prepared to be in question and answer session. So this is our early conclusions. So the two-hub Starlink connectivity is not that ideal for RAN backbone due to limited bandwidth and also perhaps the properties of the latency. And one-hop Starlink are still sufficient to be used, since we may have good options on download capacity, and then also the upload still sufficient. Why we measure something like this as matters? Let's take a look at some of data. Sorry, need to go to the end of my slide we prepare. So this is one of our administrators in GB trying to measure purely only about DMZ traffics. I mean, it's like the servers, webs, and maybe like academic server database and everything. But you know, emails already uploaded to Google's and there, right? So this is purely some services in our campus. And we try to make some profiling, what is the capacity. So here in up to like around 30 and 60 for the down. Sorry, outgoing is around 60 and 30 for the inbound traffics. So meanings like when we refer to the earlier conclusions that there may be some situations that in a city is totally disconnected. But how that university, for example, can connect to the internet by using satellite. I remember like AIT in the past in Thailand, right? Whenever like floodings and effort within the RAN communities trying to provide assistance to make their academic system up and running for the students, something like that. So we may have something like that, but at least from this type of profiling, when we have the capacity like the ones Starlink provided, as long as being used only one site, for the site that are suffering the emergency situation, I think could be useful for this situation. I guess that's all. Thank you.
All right, thank you, Abbas. So that's the report on the emergency drill. I think maybe one thing that you probably never heard in other places that in this emergency, the group is doing 2 hops of Starlink, not the use Starlink for commercial, mostly for download, but to think about Starlink as a backup for on-premise services. So as he mentioned in the last message, is email services such as emails has been put into the cloud, but there are still on-premise services running mostly for the academic purposes, and profiling what's the requirement is important. That is, in the case of something happened, that the terrestrial line is down, you can switch to backup using Starlink to increase the SLA. I don't know what happened in your places, but I think the UB's ISP gave a 99.95 SLA, right? So yeah, just to cover the next 0.4 percent is something that is still viable for this. So I think that's one of the conclusions of that. With that, I would like to open for Q&A. Anyone who would like to ask questions, just raise your hand. Thank you. Go ahead.
Okay, thank you, Awas. Can we run something like a tunnel, BGP tunnel in the Starlink mode? And then how about the hopes? Did you find the hopes
Okay.
when you and then where the nearest gateway? Because I heard the Starlink will put many gateway in Indonesia, especially in Java.
Yeah.
Yeah. Thank you.
Thank you. The question is related with can we utilize the BGP tunnelings between the two endpoints over the Starlink connection, right? So the natures in the Starlinks, as far as I understood, it's basically behind the NAT, behind the CG NAT that being employed at each of the gateway, Starlink gateway, the ones that we do not know. That's the property of the company. So in our experience, we cannot, we cannot do that. At least fail to do that. So that's why we do two options, actually using MikroTik's EO, Ethernet over IP, and also WireGuard. WireGuard. Yeah, WireGuard VPNs. So that's the two sufficient to do, helping like at least the two endpoint have the L2 connectivity. Yeah, I know for the BGP can also for multiple, right? Multi-hop, but that's usually for the iBGP ones, right? But the things we haven't really identified what's the main technical problem, but in fact cannot do that VPNs directly from the BGP.
So, but the creating tunnel then BGP works.
Yeah.
Can you have like a L2TP tunnel, something like that?
Oh, L2TP tunnel, we don't use that because the performance is much lower.
Oh, okay.
Yeah.
Yeah.
So actually, we have other experiments, right, Sunny, but we haven't compiled yet. We have many other interesting experiments for measurements. As you see, like I think you also mentioned regarding the which gateway being used, and then like, is there any effect on the latency when they are changing, something like that? There is. We observe something. I think several papers already published, and then we try to contribute to those publications also.
Okay. One thing is that did you have like using the domain, like the tunnel domain tunnel, and then you put the different one domain, and then you have a tunnel to this domain, and then when this is transparent, like when one node is down, and then all the this domain is directed to which one you want to.
Meaning like the control planes of the tunneling. So
yeah, something like that.
Well, for the tunneling, we plan for the other solutions also with the WireGuard, but we haven't really deployed that yet.
Okay.
Yeah, there is a possibility in doing that.
Okay, thank you.
Sure.
All right. Yes. Question?
Yes. Hi, my name is Tashi. Just wanted to, I don't know, compliment or add more to that. Tunnelings, I think, as long as the underlay is latency, your tunnels don't really help because it's the Starlink's underlay that dictates the latency. Yeah.
Yes.
Tunnel is just a session. So it was very interesting to see that jump in latency, which is almost 8 times your regular terrestrial latency. And it's interesting. I think your experiment, I think I really like it because for a regular, like you said, a single hop use case, I think it works really well. But in your case, you were trying to do pretty much a point-to-point
Yes.
Approach. And maybe this is where, if you really want to leverage Starlink for this kind of a backup, maybe more conversations to be had with Starlink, because they have what's called the inter-satellite laser links without you having to come down to a ground station. Maybe they don't expose that, but that might be something to explore so that you actually understand what is the true underlying latency. Because in this case, there's no visibility of, like you said, the latency jump of 8 times is very high. But tunnels or not, I think that really doesn't matter because the underlays latency has already decided what your overlays latency is. So just wanted to add that comment there.
Yeah.
Thank you.
Thank you. Thank you. That's important comments. Yeah.
Yes, go ahead.
Hello, Marla from the Philippines.
Yes.
Not really a question, but more of just thinking, is it also interesting idea to explore the possibility of implementing a dynamic traffic prioritization? I mean, during an emergency where the terrestrial link was cut, only Starlink, maybe we can prioritize critical emergency traffic or first respondent traffic on that Starlink link since we have limited bandwidth.
Sure. I guess that's an interesting avenue to try on.
Yeah.
Also. Thank you.
Yeah, I think that's a pretty good observation as well, because with the tunnel that we have, the endpoint is it's not directly connected to the Starlink as the ISP as the upstream,
no.
right? So the upstream is still your ISP.
ISP.
So it means that prioritizing traffic, you just talk with your current ISP instead of talking with Starlink.
Yes.
Right.
Yes.
So that's how things work. So instead of dealing with Starlink, dealing with your own ISP as long as the tunnel is there, right?
Yeah.
And the BGP is there. Right. Okay.
So we cannot really access the Starlink ones.
It's a black box.
And even when I asked the company, the data they have or the control they have is very limited also. It's just like other reseller kind of thing.
Yeah. All right. Okay. Any other questions? Yeah, Keiko-san, go ahead.
Hi, 2 questions.
Ready.
Well, Starlink is these days very cheap. How about having a lot more Starlinks? How about utilizing multiple
Starlink as
in some ways? There are several ideas we could come up with, like combining the bandwidths or just distribute to the department building and then autonomously connecting somewhere. But it should be very much organized way when they switch to that mode. But what do you think? Multiple utilization of Starlinks.
Yes.
But it's still very, very cheap.
Personally, I agree, Sensei, because the idea to combine came up when we discussed actually during the Unsrat. So when this capacity is not enough, how about several ones? So of course there is, in fact, there is already technology in the industry.
The combiner.
Box, combiner.
Box.
Even they combine with 5G kind of things.
Right.
Yeah, so that would be other interesting solutions that maybe like managing with the dynamicity of the latency like that.
Right, there are several different behaviors.
Behavior.
Maybe there are some new challenges. Yeah, could be an interesting trial. And second one is how to utilize the limited bandwidths. It's been an old challenge. I mean, all days we've been working with
high bandwidth.
The satellite link, how to utilize in a disaster situation, especially. We don't want everyone to do the Windows updates, right? So it's something happy. Yeah, it should be happening. So what is a strategy to control the traffic inside of the campus to go to utilize that link? So that is involve a lot of policy making things as well, but also many technology could help. So as a very good start, and then you are very interesting position in a campus that you can make some policy proposing to the top, and then someone has to say emergency situation switch, and then someone's traffic is going to be stopped or something like that. So, but how do you think about making policy and implement that technology?
I think, as I mentioned, the idea is like employing the policy-based routings or prioritizing some traffic is commonly also being placed in many of the institutions. And in fact, in our university also doing traffic prioritizations, and we divide some when it is users. For example, like if it is profile like EduRoom, we have other specific profile for EduRooms and other something like that. So there's some possibility, and the thing is, what we I mean, it's like we haven't really tried, but at least when we receive this, I mean, like we know the fact that the bandwidth is so limited when we use 2-hop Starlinks with only like 10 or 20 Mbps, we are worrying. And that's why we try to providing what is the necessary bandwidth to be reserved. So at least that according to our experiments, at least when essential services need to be running, supposed to be at least in my university requiring 100 Mbps.
I see. Yeah.
So it means like if it is combining several Starlink nodes, could be.
I see. Yeah, thank you. I think it is challenging because the situation is changing. Like many users can have a smartphone, and some of the service can be served by that. And what is a essential service that remains in the campus network is something that we really need to, identify. Yeah. Thank you. Thank you for great work. Start point.
Thank you very much. Any other questions?
Any other questions or
Yes.
comments, please?
Go ahead.
Yeah, Karma again from Bhutan. So we also recently, Starlink introduced their service in Bhutan last month. But I never thought of having a backup link for entities such as Research and Education Network. I think very, thoughtful and interesting experiment over the point-to-point, having a point-to-point link. So I just wanted to understand, is this the collaboration between the ISP and Starlink? Or does the university, such as yours, played any role in having this 2-hop link established?
Yeah, for our experiments, is we are only like asking the service from the provider, our uplink provider, not the Starlink. So, because in many countries, many company can be Starlink reseller. So us from them, usually the ID being grouped in one. So we ordering 2 nodes, and then those 2 nodes being grouped into one group, something like that. That's according to them explanations. So meaning like
better check your
need to
reseller.
Check reseller. So every terminal have the kit ID. So that's based on the kit ID they are grouping. So. Yeah.
That's one wireless mic, so you don't have to.
When you were doing an experiment, I remember you were talking with the ISPs to wait something to happen.
Yes.
So what exactly the negotiation did you do with the ISP for that time?
It's just because it's already included in the kind of the contract, and then we just call them to activate the VPN managed one.
Oh, the VPN.
Yeah, but without the VPN managed one, we can actually survive also. That's why we are trying our like soft ether solution also is being utilized in this case, because two hops VPN like that, meanings like the control plane is still placed in one of their data center in some way next to their gateway. That's become like from UB to here and from here to Unsrat. So that's why creating something. But other solution, as long as you can have some things on the internet reachable, right? Expecting close enough to one of the gateway of the Starlinks. I mean, it's like with the lowest latency, as Basuki also mentions, like how about is detecting something based on the latency? We can provide several VPN gateways and then do that VPN, site-to-site VPN. So basically site-to-site VPN. So meanings to answer your question, we can rely, if your Starlink reseller provides some service, usually for the business one, we can ask some help like that. It will reduce the complexity of providing the VPNs because, of course, the resellers with the big one, they have the capacity to provide some sort of the VPN gateway. But if you don't have such kind privilege, let's say the two side is just subscribing to two different reseller or directly to the Starlink, still you can survive with providing some VPN gateway somewhere else on the internet, and then doing site-to-site one. That's what we experimented.
All right, thank you. Anyone? Okay, otherwise, I think that's the end of the Abbas talk. Thank you very much. Applause. All right, and with that, I'd like to close this session. Thank you very much, everyone, for attending. So this has been a SOI Asia Research Workshop. We had 3 talks, one from Chong on the IoT, and then by Niswar in the cybersecurity with the network time, and the last with Abbas with the Starlink emergency drill. So this is a brief introduction of what we're doing in the SOI Asia. And tomorrow, we will have our meeting downstairs. We will have students doing poster sessions as well as demo. We invite you to come and see what they're doing and what we're doing. And we can have discussions on how we can collaborate more in the Asia Pacific and the research in the networking and other things. Thank you very much. And big applause for everyone. Thank you very much.